In 14.4, we're going to get further into definitions of trig functions. We will look at using the reciprocal identities to find function values, which if you watched my video for 14.3, I talked a bit about already. We'll look at determining signs for trig functions of non-quadrantal angles, so being able to tell if a trig function is in the first, second, third, or fourth quadrant, what the sign would be, whether it's positive or negative. We'll talk about the ranges for the trig functions, and we'll look at how to find all function values given one value and the quadrant. So for example, if you're told that sine of theta is 3/5 and that it is in quadrant 2, being able to find all the trig function values. And then we'll look at a couple of rules, specifically the Pythagorean and quotient identities, in order to help us find function values. So here are the reciprocal identities, and like I mentioned, if you watched the video for 14.3, I talked a bit about how the sine is the reciprocal of the cosecant. And so, seeing here, sine of theta is 1 over the cosecant of theta, and cosecant of theta is 1 over the sine of theta. So really just saying that they're reciprocals of each other. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So we've got our sine and cosine, and so the reciprocals for that are the cosecant and secant. So you just mix your non-cos and your cos together to get the reciprocals, and then tangent and cotangent there. So the first problem here, find the cosine of theta, given that the secant of theta is 5/3. So cosine and secant are reciprocals, so the cosine of theta would be equal to 3/5. And then the second question here, find the sine of theta given that the cosecant is the square root of 12 over 2, or negative square root of 12 over 2. Now really, if you were to answer that the cosecant of theta was negative square root of 12 over 2, I would be a little concerned because you hadn't reduced the square root of 12. Now they're just giving that to us as part of the question. But one thing we could do would be to simplify that first. So you might recall that the square root of 12 is the square root of 4 times the square root of 3, so 2 square roots of 3. Well, 2 square roots of 3 over 2 would be just the square root of 3. Of course, it's all negative, so the 2's cancel out. We just get the negative square root of 3. So really the cosecant of theta is negative square root of 3. The sine of theta will be the reciprocal of that. Of course, that ends up giving us negative 1 over the square root of 3, which is a problem in itself. We saw this also in 14.3. So we have to rationalize the denominator by multiplying by the square root of 3 over the square root of 3. And we get negative square root of 3 over 3. So that's really what the sign is there. And again, there's other ways that you could do that. You could certainly do that in somewhat different order there with when you decide to reduce that square root of 12. But whichever way you do, you need to come up with negative square root of 3 over 3. Here we're going to talk about how to determine the signs of the trig functions of non-quadrantal angles. And of course, I don't like to have you memorize things. I would rather have you go back to thinking about the basics. So all of our trig functions, sine, cosine, tangent, and their reciprocals, are just ratios of x's, y's, and r's. The thing that we know, of course, right away is that r is always greater than 0. It's a non-directional distance, so it's always going to be greater than 0. So whether you're in the first, second, third, or fourth quadrant, r is greater than 0. So the only things that can change signs are the x's and the y's. And of course the x's are positive on the right side, and the y's are positive on the top. And then they're both negative in the third quadrant. So as long as you can remember that, which should be fairly simple, then it's just a matter of remembering your trig functions and what they're based on. So recalling that the sine values are based on the y's with the r, and the cosines are based on x, and then the tangent uses both x and y. So thinking of that, of course we know all the trig functions are positive in the first quadrant, but the sine and its reciprocal cosecant are going to be positive on top. Okay, and that's because sine and cosecant combine y with r, and y is positive on top. The cosine and its reciprocal, the secant, are going to be positive on the right side because they combine the x value with the r value, so those are positive on the right side. The tangent and cotangent use both x and y, so they're going to be positive when x and y are the same. So in both the first and the third quadrant, tangent and cotangent will be positive. Again, I'm not big on having you memorize things, but if you go back to the basics and just think about your x's and y's where they're positive and negative, and think of what values x, y, and r are combined in the trig function, then you should be able to figure out whether the trig function is positive or negative based on the quadrant. And so here we have a chance to practice that. We want to determine the sines of the 6 trig functions of an angle that's in standard position given the degree measure. So the first angle, 87 degrees, that would be in the first quadrant. And so really all 6 trig functions are positive. So that's really all there is to that. So of course we'd want to write that down. For example, or question B, 300 degrees. Again, if you want to sketch that out to get an idea of where that is, but 300 degrees would be in the fourth quadrant. Because again, this is 270 degrees, and then of course 360, so we'd be in the fourth quadrant. Now in the fourth quadrant, the x's are positive. The cosine and the secant use x with r, so over here the cosine and the secant would be positive, and the other trig functions would all be negative. So only the cosine and secant would be positive here. The other 4 would be negative. That's another thing as well, once you realize with those trig functions that, of course, other than all 6 being positive in the first quadrant, there's only ever a pair positive in the second, third, and fourth quadrants. So once you can figure out which were positive, then the other 4 would be negative. For the third question, negative 200 degrees, so we talked about this a little bit earlier in the unit. Finding a coterminal angle with a positive rotation can be helpful for determining where that terminal side would lie. Of course, negative 200 degrees isn't that tough either, but if you add 360 to that, you get a total of 160, and a 160 degree angle would be somewhere over here in the third quadrant, and that would be the same as a negative 200 degree angle. So we're in the second quadrant. Again, second quadrant is on top of our system there, so the y values are positive. Sine and its reciprocal cosecant use y with r, so those would be the 2 positive trig functions in the second quadrant, sine and cosecant. So the other 4 trig functions would all be negative. So sine and cosecant would be positive for negative 200. The other 4 trig functions would all be negative. With these questions, we'll take a little bit different approach to using the signs of the trig functions. So for the first example, we were told that the sine is positive and the tangent is negative. So that eliminates the first quadrant because all the trig functions are positive in the first quadrant. So then we're just looking for where the sine is positive and the tangent is negative. And again, recall that the sine is positive besides the first quadrant. It's only positive in the second quadrant because again it's based on the y value. So for the first one, this would be quadrant 2. For the second one, it says the cosine is negative and the secant is negative. So cosine and secant both being negative. The thing with this question is that there is more than one possible quadrant because cosine and secant are reciprocals of each other. So they're both negative in two quadrants that are the same. Again, cosine and secant are based on x and r, so whenever x is negative, these would be negative. So this would be in both quadrant 2 and quadrant 3. So again, sometimes it might be more than one possibility depending on what you are given. But really that should only happen if you're given the reciprocals. So again, just a different way of kind of looking at that to think about where the trig functions are positive and where they're negative. And again, using the chart can help you get used to that, so you can see where those different things are positive or negative. But again, if you start to think of it in terms of x's and y's, then hopefully we can all remember where the x's and y's are positive and negative. In order to talk about the ranges of the trig functions, I want to look at these series of angles theta that are in the first quadrant and what's happening with the values of specifically y and r for this example. So in the first kind of shot of this, the theta is fairly small. The r, again, is much longer than the y. And what we do here throughout is we keep the r value the same. Well, as you increase the theta value, the y increases, but it never actually gets to be the same as r. So in the first quadrant here, y is always less than or equal to r. If you divide both sides by the positive number r, then you get y over r is less than or equal to 1. And again, it's important that we know r is positive, because if we divide both sides by negative, then we have to flip the inequality. So y over r is going to be less than or equal to 1. And again, only equal to if the theta is actually 90 degrees. So that gives us an inequality here. And again, same thing, we could do the same thing down in quadrant 4, and we'd end up with negative 1 is less than or equal to y over r. Short story longer, really what that ends up meaning is the sign has to be between negative 1 and 1. The cosine, likewise, which is based on the x value, also has to be between negative 1 and 1. So, again, one of those things that I suppose I am asking you to kind of just memorize, but just that the range of the sine and cosine are between negative 1 and 1. So we looked at the sine and cosine having ranges between negative 1 and 1. The tangent and cotangent are a little bit different, being that tangent is y over x, and x can be less than y, x can equal y, or x can be greater than y. So y over x can really have any value. So tangent of theta, the range for that is all real numbers, just like cotangent of theta. Now secant of theta and cosecant of theta are reciprocals for cosine and sine. So that means that secant has to be outside of negative 1 to 1. So just outside of negative 1, so it cannot have values between negative 1 and 1. And likewise cosecant is the same. Here's a chart summarizing that. So sine and cosine, the absolute values of y have to be less than or equal to 1. In other words, the interval is negative 1 to 1. Tangent and cotangent, the range values for y is all real numbers. In other words, the interval is negative infinity to infinity. And for the secant and cosecant, the absolute value of y has to be greater than or equal to 1. In other words, the interval is the union of negative infinity to negative 1 and 1 to infinity. So again, it really, once you chunk it down into, really there's only 3 different ranges for that, then it gets to be a little bit easier to manage. And here we're going to take a look at just practicing with that and determining whether each statement is possible or impossible. So the first one, sine of theta is equal to 2.5. Well, we know the range for the sine is only from negative 1 to 1. So this would be impossible. The second statement, tangent of theta is 110.47. Well, the range for tangent is everything, all real numbers, so that certainly is possible. Then we have the secant of theta is 0.6. Again, secant being the reciprocal of the cosine means that the secant's range has to be outside of -1 and 1, so this would be impossible as well. So again, just a different way of practicing our understanding of the ranges for those different trig functions. Here we'll take a look at how we will find all the function values given one value and the quadrant that it lies in. With that information and the Pythagorean theorem, r squared equals x squared plus y squared, where r has to be greater than 0, we can determine all the values for x, y, and r, and once we have those we can find all the trig function values. So if we have an angle theta that's in quadrant 2 and the sine is 2/3, then we can find the values of the other 5 trig functions. It might help, especially when you're getting started with this kind of thing, to make a sketch of that situation. So we're in quadrant 2, so our theta is a terminal side in quadrant 2. And so if we have 2/3, remember the sine of theta is y over r. So when we draw our right triangle, our y value would be 2, our r value would be 3. So so we don't know the x, the y we know is 2, the r we know is 3. So we can use the y and r in order to find the x value. And so we will use our equation here in order to do that. Now if we solve that for an x, then we can do that. Otherwise we can just plug that right in as it appears. So if we do that, we would have r would be 3, so 3 squared would equal x squared, we don't know x yet, plus y squared, which is y is 2, so 2 squared. So we end up with a 9 equals x squared plus 4. Subtracting the 4 gives me 5, so 5 equals x squared. So x squared would have to be the square root of, or x would have to be the square root of 5. Now typically we would do a plus or minus when we square root both sides. In this case though, since we know we're in quadrant 2, we know the x value is negative. So x would be negative square root of 5. Once we know that x value is negative square root of 5, we already know the sine of theta is 2/3. So we actually didn't even really need to do anything to find the cosecant of theta would be 3/2. And now that we know x, we can find the cosine of theta would be negative square root of 5 over 2. And the tangent of theta would be just y over x, so 2 over negative square root of 5. Now we've had to do this a few times at this point where we have to rationalize the denominator. So we multiply top and bottom of that fraction by the square root of 5. So we end up with 2 square roots of 5 over 5. And I'm probably just going to put that negative on top of the fraction. So negative 2 square roots of 5 over 5 for the tangent. So we already have the cosecant. We need the secant. So secant of theta, again, is the reciprocal of the cosine. And cosine was negative square root of 5 over 2. Well, that's my mistake. The cosine would be negative square root of 5 over 3. Sorry about that. I put that over the y instead of the r. So cosine negative square root of 5 over 3. Secant, so it would be 3 over the square root of negative 5, or negative square root of 5. And again, I would have to rationalize, so I'd go negative 3 square roots of 5 over 5 for the secant. And so the last trig function we would need would be the cotangent again, cotangent just being x over y is just negative square root of 5 over 2. So yeah, there we go. So that's all 6 trig functions. Again, really we use the trig function that they give us to figure out, in this case with sine, we can determine y and r. And we use the Pythagorean theorem, r squared equals x squared plus y squared. We use that in order to determine the other value, which in this case was x. And when we do that, again, it's unclear whether that should be a positive or negative square root of 5. That's where we use the fact that we're in quadrant 2 to know that the x value would be a negative. And so then we know that that is a negative square root of 5. And once we have all 3 of those, it's really just a matter of coming up with those 6 trig function values, making sure we do rationalize denominators. Here are a couple of identities. We've got the Pythagorean and quotient identities. Pythagorean identity really just replaces your x squared and y squared really with sine squared and cosine squared. So you can see kind of how they get to that. Very standard kind of trig identity, sine squared plus cosine squared equals 1. We're actually, for the most part, going to not really make use of this. We're going to just stick with using the process like we just went through. But I wanted to show you these anyway. And then a different way of writing that, just dividing by x squared instead of r squared, changes this to tangent squared plus 1 equals secant squared of theta. So there's different ways that we can write that identity. And then the third one, 1 plus cotangent squared of theta equals the cosecant squared of theta. So those are really the 3 Pythagorean identities. And like I said, I wanted to show you these, although we'll stick with using kind of the same process we just went through instead of these identities. So here are those 3 identities just listed out without the work there. So again, those are the Pythagorean identities. And then we have our quotient identities here, that the tangent is the sine over cosine. Again, a very typical identity that we can use. And then if we do the reciprocal for that, the cotangent is the cosine over the sine. So again, very similar to using like the sine is y over r, cosine is x over r, tangent being y over x, so we get the sine over the cosine. Again, very typical trig identity. For the most part, though, we're going to again kind of not get too much into using these, but I thought you should at least see them. So here's another problem. Given the tangent is 4/3 and we know that theta is in quadrant 3, finding, in here in this case they just want the sine and the cosine. Again, we could use some of those identities we just went through. For me though, at this point I think I would rather just draw a little picture of this. So if my theta is in quadrant 3, be somewhere down here. Tangent is 4/3. So if I draw my right triangle, then I know the tangent is y over x, so y would be negative 4, x would be negative 3. So once I know x is negative 3 and y is negative 4, all I really need to do is find r. I can find r using just the regular Pythagorean theorem, r squared equals x squared plus y squared. Of course, in this case you may have looked at this and realized this is a 3, 4, 5 right triangle. If we were to go ahead and square the negative 3 and square the negative 4, we would get 9 and 16, and we would see that r squared would be 25. So r would of course be a positive 5, and again r can't be negative because it's a non-directional distance. So then finding the sine of theta, sine is just y over r, so negative 4/5 for the sine. Cosine is x over r, so negative 3 over 5. And so we can find those 2 trig values fairly quickly. And again, the other 3 wouldn't be very difficult to find because we already have the tangent, so the cotangent must be 3/4. And if I know that the sine is negative 4/5, then the cosecant would be negative 5/4. And if the cosine is negative 3/5, then the secant would be negative 5/3. But they're only asking for sine and cosine, so we'll just stop there. And hopefully this was helpful for you getting a further understanding of how the trig function values work.